This is a screenshot from an exercise on Khan Academy. It says, the interactive graph below contains the graph of y is equal to log base 2 of x as a dashed curve, and you can see it down there as that dashed curve, with the points 1, 0 and 2, 1 highlighted. Adjust the movable graph to draw y is equal to 4 times log base 2 of x plus 6 minus 7. And so if you happen to have this exercise in front of you, I encourage you to do that. Or if you're just thinking about it in your head, think about how you would approach this. And I'll give you a hint. To go from our original y is equal to log base 2 of x to all of this, it's really going to be a series of transformations. And on this tool right over here, what we can do is we can move this vertical asymptote around. So that's one thing we can move. And then we can also move 2 of these points. So where we're starting is we are starting right over there. And so let's see. And that was just the graph of y is equal to log base 2 of x. So let's just do these transformations one at a time. So the first thing I am going to do, instead of just doing log base 2 of x, let's do log base 2 of x plus 6. So if you replace your x with an x plus 6, what is it going to do? Well, it's going to shift everything 6 to the left. And if that doesn't make intuitive sense to you, I encourage you to watch some of the introductory videos on shifting transformations. So everything is going to shift 6 to the left. So this vertical asymptote is going to shift 6 to the left. It's going to be, instead of being at x equals 0, it's going to go all the way to x equals negative 6. This point right over here, which was at 1, 0, is going to go 6 to the left. 1, 2, 3, 4, 5, 6. And this point, which was at 2, 1, is going to go 6 to the left. 1, 2, 3, 4, 5, and 6. So far what we have graphed is log base 2 of x plus 6. So the next thing we might want to do is, what is 4 times log base 2 of x plus 6? And one way to think about it is, whatever y value we were getting before, we're now going to get 4 times that. So when x is equal to negative 5, we're getting a y value of 0, but 4 times 0 is still 0. So that point will stay the same. But when x is equal to negative 4, we're getting a y value of 1. But now that's going to be 4 times higher because we're putting that 4 out front. So instead of being at 4, instead of being at 1, it's going to be at 4. So this right over here is the graph of y is equal to log base 2 of x plus 6. And then the last thing we have to consider is, well, we're going to take all of that, and then we're going to subtract 7 to get to our target graph. So whatever points we are here, we are now going to subtract 7. So this is at y equals 0, but now we're going to subtract 7. So we're going to go down 1, 2, 3, 4, 5, 6, 7. I went off the screen a little bit, but let me see if I can scroll down a little bit so that you can see that. See, almost, there you go. Now you can see I moved this down from 0 to negative 7, and then this one I have to move down 7. 1, 2, 3, 4, 5, 6, and 7. And we're done. There you have it. That is the graph of y is equal to 4 times log base 2 of x plus 6 minus 7. And we are done.